Today, I'm going to explain to you AWS IAM, or Identity and Access Management, to resolve any confusions that you may have had around this service. Let's begin with users. IAM users are individual entities such as people or services with long-term credentials. Long-term credentials can either be a username and password to access AWS Management Console like this one, or it could be access keys for programmatic access. These long-term credentials let these people or services access your resources continuously. Whenever you first create an AWS account, you're prompted to enter what's called a root user email address. And after you've created your account, AWS will create what's called a root user for you. One of the problems with using a root user is that it has access to everything. It has unlimited power. You can create any resource, change any resource, delete any resource. So if your account gets compromised, typically you're pretty screwed. That's why it's a good idea to create users for specific job functions that your users will need access to. For example, it is unlikely that your TechOps department will ever need to delete a database, so you should not allow them to do it. Here you can see I have 3 different users. I have admin, which is like root with most of the permissions the root has. Then I have this codevev account that I use for mostly just for videos, honestly. And then I have this Twilio SQS user. And that one is interesting because when I was working on a simple app to track my time via text messaging, I had to let Twilio send SQS messages to one of my SQS queues, and for that I had to create a user here. That is actually not the best practice. We'll touch on that briefly later, but it's not really the topic for this video. So what you can do is create different users, as I mentioned, for different job functions, and then you can actually organize them into user groups. For example, if you did create TechOps, QA, Dev, then you could create separate groups for each of these role functions, and then you would just create new users, add them to the corresponding group or groups they need to be a part of, and then you only need to manage permissions at the group level. Let's talk about how permissions actually get managed. And these permissions are actually called policies. And here on the left, you can see I can click on policies and it will bring me to a view of all the policies that I have access to on my account. When I say all, actually, it only means managed policies. And the policies can either be managed by AWS or by yourself. There is also a third type of policy, and that's an inline policy, but here on this view, it is not going to be displayed. So if we filter by AWS Managed, we will see that AWS has predefined a bunch of different policies for us. So for example, if we need somebody to just have access to S3, then we can grant them Amazon S3 full access policy, and that's it. So if we did want to add it to one of our user groups, here I have a test group, we could go to permissions, click add permissions, and then attach policies. And we will just search for S3 and click Amazon S3 full access, and it will appear right here. Now, if you go back to policies, you will also see that we have customer managed policies. Now, these ones, I'm pretty sure were created by CDK code that I was using for deployment, but the idea is the same. These are the policies that you define. By customer, AWS means you, the owner of the account. You are their customer. So you can create a custom policy with a bunch of different permissions and attach it to a user or a group directly. And then if we go back to user groups, go to permissions, we could also create an inline policy. And by doing that, let me also explain what a typical policy consists of. Typically, I don't use the visual part, I just use the JSON part, but it might be easier for you to use the visual part. But let's go to JSON, and here we see this JSON document that defines the permissions. And currently, it says allow, but it doesn't allow any actions or resources. So let's go through it one by one. First of all, a statement is an array of policies. Each policy is this JSON object that consists of SID, which I never really had to bother with it. You can just put something here that will help you easily identify what this policy is for. Now, the effect can either be allow or deny, pretty self-explanatory. So using our S3 example, we can either allow all actions, then it will put the star in here, or we can provide only access to individual actions of S3. For example, we may want to only allow users to upload things. I think it's called put object. Okay, yeah. So if you click put object, it's gonna add this action put object in here. And then currently it doesn't have any resources, so it's actually not gonna allow it for anything. So here we can either put a star to allow uploading documents to all of the S3 buckets, or we can specify which buckets we want to allow. For example, if we go to S3, we have a couple of buckets here. We go to properties, and here you can copy the Amazon resource name, and then you would put it right here. Or you could also use a wildcard. For example, if you want to give access to all of the assets buckets in the US East 1, you can do that as well. One other thing that a policy can have, which is optional, is a condition. For example, we click here on that condition, we specify condition key, for example, IP address, let's see, source IP. Then we select IP address here. Then we say default. And then we just say something like 10.1.1.0.24, and the condition is automatically added. It says it's private IP address, okay, so we can just change it to 192, and we fixed it. Obviously, you would know which IPs you would want to allow, but the IP is not the point. The point is that you can add a bunch of these other conditions to further restrict access for certain users, groups, or roles, which we will discuss next. So what are roles? IAM roles provide temporary credentials to users, services, or other entities that may need access to your AWS account, and they don't require any long-term credentials like usernames and passwords or access keys. Basically, IAM role is a set of permissions that an entity can assume to perform some action on your AWS resource. They're only assumed when needed, and the credentials automatically expire after a certain time period. You may ask how IAM roles are different from users. First of all, IAM roles are not tied to a single user or an entity. Instead, they can be assumed by any trusted entity. That could be your AWS service, that could be another IAM user, or it could even be external providers like Google or GitHub. For example, let's look at one of these roles. Here's the one for CDK stack. And here you can see that, first of all, it has AWS Lambda basic execution role. And basically, this policy just allows putting logs in CloudWatch. And here in the customer inline policy, we see that we have these three actions: get parameter, get parameters, and get parameters by path. And then we have this resource and we allow. All this policy does is that it allows the AWS Lambda or another entity that assumes this role access to the secret management service. So your next question should be, if you're not requiring any credentials for the role to be assumed, how does it actually work? Can anybody just go and assume this role? Good question. And the answer is no, not anybody. Here in the roles section, we have this tab called Trust Relationships. And as you can see here, we have defined two trusted relationships. First of all, the Lambda function itself can assume this role. Secondly, my codevev user can also assume this role. And I'm pretty sure I did it just for testing, so I'm going to remove it for now and show you what happens when you try to assume a role that you're not allowed to assume. So let me go to this tab, and then we open a Cloud Shell session. And now I'm going to paste this command: AWS STS assume role -- role ARN, and then the ARN or Amazon Resource Identifier or whatever, and then it requires the role session name, which you can give it anything. Okay, so if we press enter, it's gonna tell us that we're not authorized to perform STS assume role on this resource. So what do? Well, let's go back and fix it. We go back to this trust policy and add another statement that we had here before. Update the policy. And now we go back to our Cloud Shell and then rerun the same command. No addition needed. And as you can see, we got a response that is not an error. So now we have assumed this role. If we wanted to, we could either upload logs to CloudWatch from this role, or we could access the secrets. I'm not going to show you how to do either of these things. That's not the topic of the video. But now you know how trusted relationships work. Now, I did mention that it also will work with GitHub or Google or other identity providers. Well, how does that work if we're not requiring any credentials? Good question. For that, you can go to this Identity Providers tab, click Add Provider, figure out whether it's a SAML-compatible identity provider, and it says here such as Shibboleth or Active Directory Federation Services, which I'm pretty sure is Microsoft, but don't quote me on that. Or you can establish trust between your AWS account and identity provider services such as Google or Salesforce or GitHub or whatever. Basically, you would just go and read the documentation for the service, and you may have to set up something in their account, and then you come back here, fill in these two blanks, click Add Provider, and this is basically it. And then whenever you want this identity provider to have access to one of your AWS resources, you just add this provider's ARN to the trusted relationship on the role that you would want it to be able to assume, and that's it. No storing of access keys or usernames or passwords is longer required. If you think I've missed something, then feel free to leave a question in the comments, and I'll see you in the next video.